All right, so example 2 here, looking at this shape here, you see that this is a triangular prism. And this one can get a little tricky sometimes. So again, we're still starting off with that volume equals big B times H. Now remember, the big B, we talked about this, the big B represents the area of the base shape. So in a triangular prism, the base shape is a triangle. And again, if you do not know that, you have to go back to 9-1 and look that up. The base shape is a triangle, even though this picture, it's not like flat on the triangles. It's not standing straight up. And where is my diagram thingy? Anyways, it's not standing on its triangles like it should be. It still has the base shape of triangles. So that means the area of a triangle is that 1/2 base times height, or as many of you prefer to use instead of the fractions, 0.5 base times height. So that means over here, in for the base, in for that big B, I'm putting 0.5 base times height times height. Now, it's really, 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 really important, and actually I'm just going to color this different so it matches. I'm going to go big B, 0.5 base height, because that's what big B is, times H. Because we have to sit here and we have to pause for a second and we have to talk about what this is. So now this H right here, this H is what we talked about in the beginning. This is the height of the prism. And that is not the same thing as this other H here. This H is talking about the height of the triangle. So it's very important that you understand the difference between those when looking at those formulas. And I guess we can now fill some things in. So looking, actually I'm going to swing this over here so we have more room. Volume equals 0.5 BH times H. Okay? So first off, my 0.5 stays the same because that's just a number. Base is talking about the base of the triangle. My base of the triangle is 4. My height of the triangle is 3. And now this is where we get sketchy. The height of the prism is something different, right? Height of the prism, remember we talked about this, the prism has to be sitting on its triangles. So if you're sitting it on the triangles, you have to think about if you were to like take that shape on your paper and kind of rotate it up. If it's sitting on the triangles, I wish I had, wait, just wait. Oh, good job. Thank you for your patience. Okay, so here, let's get rid of my pen so you can actually see me. So we have the triangular prism sitting on its not base, sitting on one of the rectangles. The height of it has to be measured when it's sitting on its bases, on those triangles, right? That is the height of it. I'm trying to get a good visual of this, but ugh. So we have to kind of think about if we were to take that triangular prism and rotate it up, kind of flip it up, what would that height be? And that height would actually be the 11 right here. Height of prism. Really, really important that you see that. I'm out of breath because I ran across the classroom to get the diagram. But anywho. All right, so calculating that into your calculator, and you could actually plug that in all at once. As long as you're showing me and I can see what you filled in for each piece there, you can just type right in 0.5 times 4 times 3 times 11, which you'll see ends up giving you 66 centimeters cubed. So just wanted to pause and kind of highlight your main formulas here. This is your main formula that you're using for a triangular prism, that 0.5 base times height. And your rectangular prism is that volume equals length times width times height.